Okay, so welcome back to part 2 of 8.1 video, and our next step is to find the vertical asymptote. Now remember, the vertical asymptote is when the function's undefined, so the denominator would have to be 0. So we're going to set the denominator equal to 0, and we'll have x plus 4 equals 0. And when we solve for x, we'd have x equals -4 because we have to subtract 4 from both sides. Now remember, a vertical asymptote will be a vertical line that the function is approaching but will not cross. Our horizontal asymptote, remember we have the three cases. Either the degree in the numerator is bigger, or it's smaller than the denominator, and last it's equal, could be equal. In this case, our degrees are the same. We have a degree of 1 over a degree of 1. So that is our case of our ratio of our leading coefficients. So our leading coefficient in our numerator would be 1 because that's the number in front of my x. And in the denominator as well as 1 because that's the leading coefficient in front of my highest degree. So the ratio of 1 over 1 is 1. So our horizontal asymptote is y equals 1. Alright, so first when you're graphing these rational functions is you want to graph the asymptotes first. So go ahead and graph those two lines and bring it back. So you should have graphed your vertical asymptote of x equals -4 and your horizontal asymptote of y equals 1. And again, these will be dotted lines. They are not part of the function. They are just where the function is approaching, lines that the function is approaching. It's actually identifying our gaps in our function. So the other, what you can do is we can use a table to find other points. But in this case, we found a point using our 0. So 3, 0 is a point in our function. So I can put a dot there at 3, 0. There are no holes, but that's another way we can find out what quadrants they're in. And in this case, our function is in this quadrant here, our fourth quadrant. And we'll use that value to help us graph it. And you just draw your line approaching your asymptotes, and your vertical asymptote and your horizontal. And then most of the ones that we'll be doing will be in opposite quadrants, and you can check that by plugging in values. Like you could plug in -5 and make sure that it would be in this range. If we plugged in -5 for x, we would get -8 over -1. So that would be a y value of +8. So that would be up here. So our graph is going to be more up here. But it would have two quadrants. It's definitely in this quadrant of, and the value of -5, 8 could be a point that helps us graph it. Okay, so there's our first example. We're going to go ahead and try example number 2 and number 3. And the first steps for number 2 and number 3 is to factor our functions. So take a minute to factor our denominator, and this will allow you to see everything so you can identify what gaps there are and what kind of gaps they are. Are they holes? Are they vertical asymptotes? So go ahead and take a minute, pause the video, and factor the denominator. Okay, so you should have x plus 3 over x minus 3 and x plus 3. And here you can see that this would be a hole, and this would be a vertical asymptote. So go ahead and try this problem on your own and then bring it back. Okay, so the first thing that should have struck you as unusual when you thought about the zero is that is the hole. And if it's a hole, it can't be the zero, and it can't also be a vertical asymptote. So when you saw that that was the hole, you should realize that there can't be a zero. If we set our numerator, our simplified function with the numerators of 1 equals 0, that's impossible. There would be no 0 for this function. Second, we're going to set the common factor of x plus 3 equal to 0 to find our x value of our hole. When we do that, we get x equals negative 3. Then we take that value and plug back into the simplified function. So if this wasn't here and we divided it out, we'd have 1 over x minus 3. So we would take that negative 3 and plug it in for x, and we get 1 over negative 3 minus 3. So that would be negative 1/6. So our hole is at negative 3 and negative 1/6. For our vertical asymptote, we're looking at our simplified version of our function, and we would set the denominator equal to 0. So x minus 3 equals 0, and it would have a vertical asymptote of x equals 3 when we solve for x. For our horizontal asymptote, our degree in the bottom is bigger than the degree in the top. So it would have that first case that we talked about of y equals 0. Okay, go ahead and pause and try to graph this and then bring it back. Okay, when you graphed your asymptotes, they should look like this, and then your hole, you do want to graph it with a hole, with a circle empty set, because that's is discontinuous in that value there. All right, let's look at the next problem. Again, we're going to have to factor to see if there's any holes here. So take a second and factor that numerator and see if you can uncover a hole. When you factored x squared minus 2x minus 8, you should get x minus 4 times x plus 2, and that uncovers a common factor, so that is going to be a hole there. So our simplified function will be x plus 2, y equals x plus 2, but there will be a hole in it. It's going to be a line with a hole in it. So go ahead and try to graph that and bring it back. Okay, so to find the 0, we set our numerator equal to 0 and solve for x. In this case, x plus 2 equals 0, and our 0 would be negative 2 and 0. Our hole, again, is the common factor, so we set that equal to 0 and solve for x. And x minus 4 equals 0. When we solve for x, we get 4. Then we plug into the simplified function. So y equals x plus 2 is our simplified function. So that would be y equals 6. So our point for our hole is 4, 6. And then our vertical asymptote is when the function is undefined and there is in the denominator, and our simplified does not have a denominator, so there won't be a vertical asymptote. And for the horizontal asymptote, our degree in the numerator is greater than the degree in the denominator, so there will not be a horizontal asymptote either. So we graph our line like we're used to graphing line with our y-intercept of 2 and our slope of 1. We can also plot our 0 to help us. And we also want to make sure we show the gap in the domain and in the range of at the point 4, 6. Okay, thanks for watching. Have a good night.